Hi, welcome back to LeetCode. Today I'm going to discuss LeetCode problem 921. Minimum add to make parenthesis valid. So a parenthesis a valid string is valid if and only if it is an empty string, or it can be written as A, B, A is concatenated with B, or A and B are both are valid strings, and or it can be written as open parenthesis A then closing parenthesis where A is already valid. Okay. So you are given a parenthesis string is in one move. You can insert a parenthesis at any position of the string. For example, this is the input string. String is opening bracket, closing bracket, closing bracket, closing bracket. So is this actually valid parenthesis string? No. Why? This actually have opening and closing bracket. This and this bracket does not have any opening bracket. So that's why this is not valid. So if I have to make this actually valid, so then what I have to add? One opening bracket and one opening bracket. This is for this and this is for this. So how many actually parentheses I have to add? 2. Okay, that's why you can insert opening parenthesis 2 or a closing parenthesis to this. Okay, return the minimum number of moves required to make a split. So we have to find out minimum number of parentheses we need to add. Now for this example, opening bracket, closing bracket, closing bracket. So this is already valid. This opening and closing bracket, this is not valid. So that's why the answer will be 1. You can check, that's why answer is 1. Now go to the next example, opening bracket, opening bracket, opening bracket. Okay, so for this opening bracket there is no closing bracket. For this open bracket there is no close bracket. Similarly for this. So how many actually opening bracket have that actually do not have actually any closing bracket? 3. So that's why the answer here will be 3. Okay. Now ultimately what I have to check? Suppose this is our string. Input string is this. Okay. Now whenever we are actually getting any open bracket, to store this into a stack. Okay. Okay. So first 3 I have to store this into a stack. Now whenever getting any closing bracket, then when it will be actually valid. It means if and only if there is any open bracket present before it current position. So for this closing bracket I have already seen an opening bracket, so this will be actually matched and this will be valid. So I will actually pop this from the stack. So this is actually valid. Now again we got actually another closing bracket. So I'll check, is there any open bracket present? Yes. So this will be valid. So I will actually pop this from the stack because this is valid. Again I got another closing bracket. So I'll check, is there any open bracket present in the stack? Yes. So I'll just pop this. Okay. Now ultimately I will check, and I have completed the iteration of the input string. Now I'll check, is there any open bracket extra? So I will check, is there an open bracket extra or not? I will check in the stack how many actually extra open bracket are present. Okay. If there is any open bracket that will be present in this stack, right? If it is empty, means there is no open bracket extra. Now this actually check how many actually we need actually closing bracket. If there is that many times we will need actually closing bracket, whatever the number present in the number of open bracket present in the stack, that actually indicate that how many actually closing, to balance this, to validate this, we need to add those many same number of times closing bracket. So that's why I'll check how many actually open bracket here. So that I have to add. Now suppose we are seeing, suppose this is the input string. Okay, closing. Now for this closing bracket the stack is empty because I have not seen any open bracket till now. So I'll check, there is no open bracket, so I have to add one closing bracket, opening bracket for this closing bracket. So our answer will be increased by 1 because for this position, for this closing bracket there is no open bracket. That's why I have to add one open bracket. Similarly for go to the next still our stack is empty, but we are expecting that there should be any open bracket. There is no open bracket, so again I'll actually increased by 1. So currently our answer is 2. Similarly for this I'll check current character is closing bracket, but our open bracket stack is empty. So that's why we need to add one more bracket here. So that's why answer is 3 here. Got it? To make this fit, you can actually validate this. If I add these 3 open bracket and our closing bracket is already present, this. So this is already valid. These have 2 valid, these 2 valid, and these 2 valid. Okay, correct? It is clear. Logic is clear, and the problem and the approach are also clear. If you like the explanation, please like the video, and if you not yet subscribed, please subscribe the channel. Now what is the step? First of all, I will check, I will iterate the input string. If it is our closing bracket, then what do I expect? Our check that is there any open bracket. If not present, then our answer will be increased by 1. Else, if it is present, then else what I will do? I will just pop that bracket, because this is matched, this is valid. Okay, now one another situation can possible, this is actually the open bracket. So ultimately I'll just store this in stack, correct? So this is open bracket. Now ultimately after all this operation, now you can check after in between the iteration of the input string, I have calculated the how many actually open bracket I have to add if there is invalid valid in parentheses. Here actually you by in this way, like I'll check is there any open bracket, is it not present, then I will already increase in the answer, correct? In this actually I will actually check how many actually open bracket I have to add. Now for this situation, when we have extra open bracket, that time how many actually closing bracket we need to add, that how actually I can actually find out. I can find out that what is the number of open bracket present in the input stack, the stack, that I have to add. Answer will be increased by this stack size. That actually indicate that how many actually closing bracket we need to add. That will be our answer to make this actually valid. Got it? So just go to actually code. So our initial result is 0. Okay, and now we have taken a stack where is storing the character, and I am iterating the input string s. I'll check if it is the current character is closing bracket. That time I'll check if our stack is empty, that means I have not seen any open bracket till now, or I have seen but this is not present or not valid. So that time I will increase the result by 1. Else I'll just validate this and I will pop that open bracket from the stack, correct? Now else if our character will be open bracket, so I'll just push this into a stack, correct? Now in this actually I have actually already calculated how many actual open bracket we need to add for closing bracket. Okay, how many actually open bracket we need to add. Now I'll check if I have any extra open bracket already in the stack. If a stack is not empty, that time what I'll do, I'm just that many times actually I have to add this. So result plus and stack pop. So it will actually just pop the open bracket. So that many times actually I have to add also the closing bracket also. That's why just increasing the result. Okay, and at the end return the result, correct? It is clear? It's simple, I think. Please try to actually you can actually try to take some example. It will be more clear then. It will be, and you can try to implement by your own actually. Now what a time consider this time setting. So here actually we are iterating the input string. So if the string length is big of L length is L, then time set big of L. Okay, here actually the same big of L maximum. Okay, so time set can be maximum big of L. So what is space complexity? Space complexity, we are taking a stack here. It can like all can be open bracket, so it will be all stored into the stack if there is no closing bracket. Okay, so that time the space complexity will be again big of L, correct? It is clear? Please like the video if you like the explanation, and also if any doubt, any suggestion, you can comment on that. And please like this and please subscribe the channel if you not yet subscribed. Thank you.